All right, everybody, welcome to the video here going over our practice with linear functions worksheet from class today. So I want to just take a couple minutes and go through the answers to this so that we all understand what we need to be able to do for tomorrow's quiz. So for the first question, this equation is not in y equals mx plus b form. So that's going to kind of be like our first job, because if we have it in y equals mx plus b form, I can graph it in the calculator, or I can graph it knowing what I know about linear functions. So, algebraically speaking, the first thing I have to do here is distribute. So I'm going to have y minus 4 equals 3x plus 6. Then I have to move the 4 to the other side. I can do that by adding it. So I have y equals 3x plus 10. Now, if I put that in the calculator, I get a whole bunch of points. But if we know the slope is 3 over 1, and I know the y-intercept is 10, I know this graph crosses at 10, and is going to go up 3 to the right 1, which I can't do here. I don't have enough graph paper. So if I go down 3 to the left 1 and go opposite, I can grade some points on my graph. The graphing calculator is a very useful tool. However, sometimes it's easier not to use it, like this one. All right, for number 2, I gave you a graph. There's a whole bunch of points labeled there for you. And I want to determine the equation of a line. First thing I notice about this line is it crosses the y-axis at a weird point. So I can't use y equals mx plus b. And I have to use y equals m times x minus h plus k. And to use this formula, I need to use a point, and I need to use the slope of this line. So if I pick 2 points on this line, and I find their slope, I'm going up 1 to the right 3. So I know the m is 1/3. And if I pick a random point on this graph, like 7, 3, I know the h is 7 and the k is 3. Now, did I have to use 7, 3? No, I could have used any point on this graph. So if we plug in what we know, we have y equals 1/3 times x minus 7 plus 3. Distribute. Use your calculator there. And combine like terms. Again, use your calculator here. And you have your equation of a line. Notice I didn't use decimals here because 1/3 and 2/3 are repeating decimals. We don't want to do repeating decimals and put the bar over the 0.3s. For number 3, we need to figure out which one has a greater slope. Well, to do that, we need to calculate some slope. So I'm going to use these 2 points to calculate my slope using the average rate of change formula. So I'm going to subtract the y values, so minus 4.5 minus negative 3, and subtract the 8 and the 2. Well, if I put that into my calculator, I get an average rate of change of negative 0.25. This is my slope. For h of x, I have 2 points that I can just count boxes and say I'm going down 6 to the right 2. So my slope is negative 6 over 2, which is negative 3. So now I have to look at these two answers and say which one's a bigger number. Negative 0.25 is the larger number, so I can say k of x has a greater slope. For number 4, this is just more practice with that new form of the equation of a line y equals m times x minus h plus k. So here we have our m, here we have our h, and here we have our k. So I can say y equals 3 times x plus 3 minus negative 3 is a plus 9. Distribute the 3 and combine like terms. For B, here's your M, here's your H, and here's your K. So I have y equals negative 1/4 times x minus 8 plus 2. Distribute. So we'd get y equals negative 1/4 x plus 2 plus 2. Right? Negative 1/4 times negative 8 is where that plus 2 comes from. Combine your like terms. And there you go. For C, I'm giving you 2 points. I'm not giving you the slope, so I have to find the slope first. So I have to do the average rate of change formula here and say negative 12 minus negative 6, right? Subtract the y values, and then divide that by the subtraction of the x values. If I put that into my calculator, I should get negative 2. So now we can pick a point. It doesn't matter which one you pick. So I'm going to pick 4, negative 6. I'm going to make this my h and this my k. So I'm going to say y equals negative 2 times x minus 4 minus 6. Do some distributing. Negative 2x plus 8 minus 6. Combine my like terms. I have minus 2x plus 2. On to the next one. Determine if each is a linear relationship. So neither of these are a linear relationship. So to do this in a table of values, you can do one of two things. You can plot all the points on Desmos and see if it makes a line or not. Or you can look at your y values and see what they're going up by. So this goes up by 4. This goes up by 8. This goes up by 16. That's different every time. These are going up consistently by 3. So for it to be a linear relationship, the x values and the y values all have to go up at the same value. They're not, so this is not linear. For g of x, these are all going up by plus 3, which we like. That means it's starting to be linear. But if you look at your x values, 2 to 15 is changing, right? That's a different relationship, so this is also not linear. Number 6, to be able to do what we did at the beginning of the unit regarding word problems, you just have to identify which one is going up at a constant rate of change. So in A, when we're talking about me setting up my college fund for my kids, even though I'm depositing $2,000 initially, I'm going up the same amount of money every month. So every month is the same amount. So that makes this linear. For B, when I'm trying to buy my golf clubs, every month is a different amount. I'm doing $10 a month, then $20 next paycheck, then $40 next paycheck. Every paycheck's a different amount, right? So each check, help to spell check right, check is a different amount of money. So this is not linear. Number 7 was just a tricky question because of the calculator work you have to do here. There's a lot of weird fractions in this answer. So the first thing you want to do is distribute the 0.5. So I have 2y plus 1/3 equals 0.5x minus 3.5. 0.5 is a nice decimal, so we'll leave that one. I then want to subtract 1/3 to the other side. Well, if I do negative 3.5 minus 1/3 of my calculator, I'm going to get a decimal. So that decimal is a 0.3 repeating or a 0.6 repeating, something like that. You need to change it to a fraction. So I could leave the 0.5x, but I'm going to make this 23/6. That's what my calculator is going to tell me if I type that in. I then have to divide everything by 2. Well, if I divide 0.5 by 2, I'm going to get 0.25. That's a nice decimal, so we'll leave that one. But if I divide 23/6 by 2, I'm going to get a nasty decimal. And that decimal is going to convert to the fraction 23 over 12. Remember, to get the decimal into a fraction in your calculator, it's math, enter, enter. For number 8, I'm giving you enough information to graph the line. So I'm giving you a point, 5, 2, 1, 2, 3, 4, 5, 1, 2. And I'm giving you a slope of 2/3, so that's up 2 to the right 3. I can do the opposite. And I can graph the line. I don't even need the equation to graph the line. As long as I have a point and the slope, I can graph my line. Now notice the y-intercept here is not a nice number, so we have to use that form of the equation of a line that we learned in lesson 3 and 4 to find this equation of a line in y equals mx plus b form. So I'm going to plug in my slope, my h, and my k. If I distribute,